Welcome to the first video in Module 4, where we finally talk about input-output analysis. In this video, I want to go over the objectives, context, and concepts of input-output modeling so that you get an overview of what will happen in the next videos, where we get into more detail and technical aspects. The outline for this section and module is that we talk about input-output tables and their components, so how they are structured, how they are set up. We talk about how to solve an input-output model and also how different production functions can be added into input-output modeling. We have the opportunity to model shocks here in this input-output model, and we will give a brief overview about how to model the future and take a look at the environment, how that is connected to the economy. The purpose and objectives here are, in this video, are really to give you an understanding of the concept of input-output models. Only if you understand the process, you're also able to criticize them and see the positive and negative aspects for the model. As always in economics, it highly depends on which kind of model you apply to which problem. Because if you only have one model, that's like trying to have a screw and only a hammer, and you try to solve everything with a hammer, which is not really optimal. So you have to really figure out what is the optimal tool for the problem on hand. So we will also look into how to apply the input-output framework independently, and we'll upload some R code for this. And it's really important to understand the working mechanisms there for the input-output tables, because in the end, you will see they are nothing else than matrices, and you can apply graph theory to matrices and therefore analyze the economy as a network. The concept is that we have with input-output models a quantitative framework to study the interdependence between sectors of firms. And what we see here is that we are able to model upstream and downstream connections in the economy. So from which sector does another sector purchase? And which sectors purchase how much from which sector? So you are able to not just look at supply chains, but we actually have the supply network for the whole economy in one matrix. And the tool of that, why it's often used input-output modeling, is nowadays for policy evaluation. We will talk about that in a second, but why I'm saying it's today used in policy evaluation. In a second, you will also see why it was also used to plan the economy. And there's a really brilliant textbook, which I base a lot of my work as well on. I highly recommend here the book by Miller and Blair, Input-Output Analysis, Foundation and Extension. I'm currently using the second edition, which highly improved from the first edition. So knowing the work that Miller and Blair put into their textbook, I'm really expecting that if a third edition is coming out in the nearer future, I highly recommend to use the third edition. They added really valuable stuff, clarified a lot of open questions from the first to the second edition. So if they keep up the great work, the third edition is really something you want to look into. The possibilities of input-output modeling is to look at economic interdependence. So it reveals which industries or sectors are how interconnected, which sectors depend on each other. What happens if we take one sector out of the equation? What happens to the whole economy? Well, if we take out the power sector from a developed economy, all the other sectors probably will crash. But if we take out another sector, or company, or industry, not a lot of impact might happen because the sector is not so relevant for the economy as a whole. We can also do policy analysis with input-output modeling. So we can predict how economic impact is of a policy change. Introducing a tax, imposing tariffs, having more planned or guided investment to see how things will play out in the medium and in the long run. We can have also impact assessments. An impact assessment for the economy would be to evaluate the effects of external shocks. So if you consider the year 2020 with a pandemic, a few years later the ship getting stuck in the Suez Channel, where we talked about resilience on that video. These are really important aspects where we want to know the impact they have on the economy. Also, technological change is something really, really important to measure and to analyze the impact of introducing new technology into the economy. We can have also regional development and environmental assessments. So relocating a firm to a specific region or providing subsidies that a firm establishes itself in a region. And this is able to be modeled in an input-output table. We can also assess environmentally perspectives. Well, we all know that rather sooner than later we have to be carbon neutral in the economy, and therefore have to understand how emissions are connected with economic activity, and to reduce emissions, how we have to adjust economic activity. And then, of course, we can run a simple supply network analysis. What I mean by simple is not that it's easily done. By simple, it means we're just looking at one firm or one specific industry, and we can understand vulnerabilities in supply chains and supply networks to point out for individual firms or industries that they have specific partners in their supply network which they are highly dependent on. I talked so far a lot about input-output tables itself. You haven't seen one until now. And what we see here, and we will go over this in way more detail in the next video, is you have pretty much several components. The main component is the intermediate consumption, the set values here. This 3x3 matrix. So what we see here is in which sector is the consumption of which sector's inputs happening. We have a final demand where we can separate between households, governmental spending, exports, change in inventory, and all of that, everything that is produced in sector 1, so set 1.1, set 1.2, set 1.3, final consumption F1H and F1X here for exports must add up to the total output in that sector. And the magic in input-output modeling is that every row has to add up to its column. So the total output in sector 1 must be equal to the total input in sector 1. So this is where value added here comes in. But I run through this here, right, fast. In the next video, we will talk more about this in details and analyze what are components in this idealized 3-sector model here. And the components, as I said, we have sectors and industries. You can run an input-output table on firm level if the data is available. So we have to represent different economic activities here. And in this input-output table, we summarize the exchange of intermediate goods and final goods. So in rows, as I said, we indicate the distribution of an industry's output to other sectors and final demand. And in the columns, we show that the inputs required from another sectors and to produce a sector's output. Final demand is really important. It shows what leaves the economy, either through consumption or export. And value added is the contribution to the GDP, like wages and profits, which is not a flow by the terms in an input-output table where we would have things flowing from another sector. But these are really important aspects to keep the economy running as well. Where's the idea of input-output table coming from? Wassily Leontief was the origin of that. He was born in the early 1900s in Russia, migrated to the US later on, and he wrote in 1941 his paper, The Structure of the American Economy, and he analyzed 10 years of the American economy. For that work, 32 years later, he got the Sveriges Riksbank Prize in Economic Science in memory of Alfred Nobel, more commonly known as the Nobel Prize in Economics. But as you all know, it is not an Nobel Prize. It's a prize by the Swedish Central Bank donated in the name of Alfred Nobel in order to make economics more look like a real science than rather applied math or a social science as it is more. The idea of Leontief was further developed by Leonid Kantorovich. He was also born in Russia and a Soviet mathematician and economist. His focus was on how resources are efficiently allocated to the industries. So coming from a Russian perspective while the Cold War, his idea was, in a planned economy, how are we using our limited resources like steel, coal, and labor in the most efficient way to have the most and best outcome. Best outcome here in the planned economy that the Soviet government was planning on. Interestingly, only 2 years after Leontief, he also won the Sveriges Riksbank Prize in Economic Science in memory of Alfred Nobel. So we have in 3 years 2 times the Nobel Prize in Economics for pretty much the same idea from different angles. And this is not just a theoretical idea that the two of them had there. Input-output table was applied to not just plan the economy, but also to manage the economy. There's a really brilliant podcast on the project CyberSyn, which I highly recommend you to listen to if you're interested. Because at the same time as Leontief and Kadyrov received their Nobel Prize, in Chile under Salvador Allende in 1971 to 1973, they ran an experiment on how to structure and manage the economy. They set up a system that was consistent of 3 components. First, they were having a network of telex machines in every factory, which they set up as the cybernet. And yes, this sounds a little bit like science fiction. And if you think of it, for the early 70s, having in every company that was considered important enough for the economy, a fax machine was pretty much science fiction. In case you don't know what a fax machine is, look it up on Wikipedia. We still use it in German bureaucracy a lot, but if you're in any other part of the world, you probably have never heard of that. And the idea was that every company reports their daily production to the central office. And by daily production, they were reporting how many products they were produced, how many people showed up to work, how many people were sick, how many hours were worked. So really, really detailed process of information transmission to the central office, something that we could do probably today quite easily because all the stuff runs automatically in every company. But back in the days, in the early 70s, they had to send a fax with all that information to the central office. In the central office, all the information came in, and the model, they used an input-output model to analyze where the economy is standing and how it will process to the future. This project and this code was called CyberStride. And then we had a really fancy-looking futuristic operations room. So it really looks like Star Trek or something like that. It's really interesting to look at that. And there people were sitting to make decisions about the economy. And this decision-making of the economy was actually used because they were able to not just see today's output in the economy, but, for example, if timber production falls down, you know that further down the road you will run into a shortage of wood in your construction processes. So they were able to mitigate and reallocate labor forces then, for example. They were like, okay, we run out of timber in construction in about 10 days, so let's start building less tomorrow in construction and have the people rather dig trenches or something like that. So this was really a well-running project, and it was used to break the US embargo because it was when Chile came under the US embargo, under the rule of Salvador Allende, the US imposed an embargo on the Chilean economy, and Chile was able to adjust really fast and adequately its economy to the embargo. Also, paid by the US was a truck driver strike to break down the Chilean economy, and again, Project CyberSyn was able to see which companies have already which stuff in stock, which one will break down further on, and also mitigated the impact of the strike here. So far, we talked about planned economies, but even in market economies, as we are more familiar with in the global north, input-output tables are used in policy evaluation. So as I said, we're introducing a new subsidy, a new tax, new tariffs, whatever. We can model that in our input-output tables. We can have an environmental impact study. Well, if we produce more steel, for example, we have to use gas. That produces more emissions. That will have an impact on the environment, but we have a carbon emission budget, which we're already running out in a few years. So we really have to adjust those things, which technologies, which industries are driving emissions, and we can adjust there. There is a computer program which incorporated that. If you're familiar with REMI, perhaps, it's mostly based in the US context. It's a regional economic modeling instrument, if I'm not mistaken. And there you can model on a really small level, county or state level, economic impacts of policy evaluation. And of course, as earlier mentioned, you have a supply network analysis, which sectors depend on which other sectors. And in a planned economy, like in Project Cybersyn, input-output tables have advantages. Because you have a centralized decision-making, you reduce the costs of decision-making as we have in a free market economy where every company has to make their own decisions. You have inefficiency through that because companies are not talking to each other of, oh, how much do you produce? How much shall I produce? We don't know how many customers we have. All that is centralized and way more efficient in a planned economy. You can also set production targets by an economy, something we also see sometimes in market economies. For example, in times of war, the United Kingdom used in World War II production targets for military goods. The US did that in World War II. There's a huge research literature on production targets with the looming climate collapse, which products do we have to focus on? We should focus on basic goods for daily survivalship rather than on luxury goods. And it's also really nice input-output table because you have a clear mathematical resource allocation. It gives you a number. You're perfect, nothing else. You have a number, you deal with it. But of course, there are extreme disadvantages to input-output tables, which can be addressed to a specific amount, not always, but a lot of them. So, for example, as we will see in the next video, we have a fixed sector relationship. So, sector 1 always purchases 20% of its inputs from sector 1, 30% from sector 2, and 50% from sector 3. So, in order to change that, we have to set up a complete new input-output table. There's, of course, a lack of realism. Even in the Project Cybersyn, sometimes by accident, wrong numbers were transmitted, which had an impact on the planning. So a small mistake can play out really huge in the end in the planning process. And what is also lacking in input-output tables, as we will look at them in the first few videos, is that we cannot have innovation or price adjustments. Both of that you can incorporate either externally or endogenously into the model. And in market economies, as I said, we're less looking at the planning stage of input-output models. The ability we really have there and what we value input-output model there is for the impact analysis. And we can have dynamic and globalized systems. So we're not just looking at 1 year, one country. We can look at the whole world over several years, how they interplay. We can model structural relationships, how they evolve over time. And as I said, especially with the looming climate collapse, we can highlight the limitations in adapting currently our industry strategy and can outline how low-carbon economic activity can help us and solve economic process and bringing that into one hand with a climate relative situation of climate-constrained economic productivity.